Hello, good morning. I'm so glad to see you. We're going to talk more about statistics today, chapters 9 and 10. 10 is actually kind of short. 9, we're really going to focus on that one graph. So here's what you can do. If after this lecture, you still have trouble understanding that graph, go ahead and read the chapter. The chapter's pretty good. She does a good job of trying to explain how all of those things work together. Skip the stuff that is more mathematically, statistically related in terms of actually making those calculations. What I want you to do is understand the concepts. So the conceptual reasons why different statistics make sense. That's what I want you to understand. So that when you're reading an article and it says we used a t-test, then you know what that means. Or they say we correlated, we used a Pearson R, then you'll be able to understand what that is and understand why that makes sense. You're not going to be sophisticated enough to understand if the statistics they used were appropriate. You're not at that level yet. You have to be a pretty high level statistician to really understand it. And it's because statistics these days are complicated. All kinds of new stuff that people are doing that is complicated. And so it is hard to be at a level where you really understand whether or not a statistic is appropriate. Sometimes people do things that are clearly, blatantly not appropriate, but usually those things are caught right away by a peer reviewer. So what I'm thinking, I don't want you to worry about it. I want you to just kind of get a sense of, oh, if we've got 2 different groups, this is what test we use, this makes sense, I understand this. The main thing that I learned is that once you put this into practice, that's when it makes the most sense. That's when it starts to really get under your skin, I guess, in a good way. That wasn't a good analogy. When it gets to really, your brain starts to capture it. I don't know, try and figure out what I'm saying, right? It's when I was at Yale doing studies there and I had to do this stuff. That's when I really got it. Graduate school, a little bit. In practice, that's when it happened. And that's when research design got really fun for me. So today we're going to talk a little bit about how you choose the right design, how you choose the right statistical test for your design. We're going to try and keep it simple. So think about the project that you're doing. You should be well on your way in terms of your study. Okay, and if you're not, it's time to start really working hard on it. Really working hard this week. And so what I'll do is I'm going to send you a detailed rubric for how I'm going to grade your paper so that you'll know exactly what you need. And then I think that will help you with constructing what you're doing. But think about what kind of testing, what kind of statistical test would be appropriate for the design that you have in mind. We're going to do some practice here. Okay, so in this figure on page 214 in your book, figure 9.2, so second figure in chapter 9, right? It discusses 3 different ways of comparing means and different ways of testing relationships. And so we're going to first look at the 3 different ways of comparing means. And so if you remember, a mean is an average, right? So you have a group and you take all of their scores and you calculate the average score, and we call this the mean. So there's 3 different ways to compare these means. The first way is if you have 2 groups. This is like maybe the most common or the most easy to begin with in terms of understanding. You have 2 different groups, and so you want to compare those groups and see if one group differs from the other group. And so you look at comparing the means of the groups. Another way is you might want to see how your group or a group compares to, say, the national average on something, or compares to some other known value. And so you're comparing one group to a known value. And the last way is you have 3 or more groups. And you want to compare their average scores with each other. There are a couple different ways to look at 2 or 3 groups, whether it's within subjects or between subjects. We'll get to that. So right now, we're going to look at this in terms of 3 ways of comparing means. Okay, so I'm going to give you examples. So let's take the first idea. You have 2 different groups. So here's your example. You've got this study of students who are eating fruits and vegetables for breakfast versus Fruit Loops for breakfast. Okay, 2 groups. And so you want to do this study looking at, does breakfast have an impact on your anxiety? Okay. And so you get your people, you have two groups. One group has the veggie fruit breakfast. The other one has Fruit Loops. And you have to think about, how do I design this? How long do they have to eat this way for me to think that it might have a difference? Like, I'm thinking if you eat breakfast and then you take your anxiety test right after you've eaten breakfast for one day in that manner, I don't think that's going to have an impact. I think your body needs some time to kind of get used to this for breakfast, or some time to have the effect of either the nutrition or the denutrition, lack of nutrition, non-nutrition, whatever. All right. And so you have to decide how long this intervention lasts. You need to randomize the people to the two groups, right? And then you need to select, how am I going to measure their anxiety? So remember, we talk about this as operationalizing. And so we're thinking, let's operationalize anxiety using a measure called the STAI, the Spielberger State Trait Anxiety Inventory. There are two different kinds of the state trait anxiety inventory. One measures state anxiety, the other measures trait anxiety. In other words, state anxiety is kind of what's going on for you currently. Trait anxiety is how much of an anxious person are you by nature. And so you can get a sense of trait anxiety using the STAI-T trait version, or you can get a sense of what their state anxiety is, which is more variable, of course, because it varies depending on the state that you're in. Not Wisconsin, not Dakotas, not like that. The state that you're in other words, the situation you're in, your circumstances, right? So if you tend to be an anxious person anyway, your state anxiety will generally be higher. If you're in a frustrating position and things are unusual, like let's say, like you're in quarantine for some reason, or let's say, your state just put in, stay-at-home order till June 10th, something like that, right? And that might increase your state anxiety depending on your appraisal of the situation, depending on your regular trait anxiety, depending on all kinds of things, how much you love your family, I don't know, you pick. So we're operationalizing anxiety using the STAI. You want to compare the scores of the two groups. So you have them eat breakfast a certain way for however long you decide, and then you want to compare their scores. So the question is, how do you compare the scores? Obviously, you can't eyeball them, because eyeballing them can be misleading. What you have to do is take account for the variance, the variability of the group. So if people's scores are all over the place and you're eyeballing for differences, it might be that they're not very different, even though the means look different, because the variability is so high, those means might not be actually different. You can think of it as like what do they call it? The standard error, or the error variance, or the margin of error. That's what I'm thinking of, the margin of error. So somebody says, okay, we took a poll, the margin of error is plus or minus, whatever, right? So for example, they are comparing Biden to Trump. Who's going to win if the election was tomorrow? Our poll says this, and oh gosh, I just forgot what I said, that the error is plus or minus. Call it 3 or something. And so what is if the two scores were pretty similar, let's say Biden versus Trump was 42 versus 40, let's call it that. And they say, well, the error would be like 4 points. Then you're like, okay, well, those are 3 points away. So it's not different. It's not actually different. So what you're doing with a t-test, which is oh gosh, big reveal is coming in the next slide, and here I wrecked it. You're like, oh, it was a t-test. Oh my gosh, the mystery has been revealed. My research and methods teacher is such a nerd. All right, sorry. Not sorry. Okay, so you're using a t-test. We'll get to that in a sec. Here is the graph for what this design might look like. So first of all, take note for when you write your procedures section. This might be relevant, useful, okay? So you start recruiting. You have to figure out, where am I finding these people? How do I recruit them? How do I get them to take part in this study? They have to sign a consent form, etc. So you recruit them, you may have to exclude some people. Let's say there are people who've been eating vegan their whole lives, and you want to exclude them. Or let's say there are people who have diabetes, and you think it might be a good plan to exclude them, right? You want to make sure that the people in the study are people that represent the population you want to apply the findings to. That's the external validity question. The people in the study represent the population you want to apply the findings to. Okay, so you recruit people, and then once they're enrolled and they complete whatever baseline measures you want, like you could say you have to complete the trait version of the state inventory or the STAI, because we want to have a sense of what your trait anxiety is. Or you could say, we want you to write in, general eating habits, whatever. There are lots of things that you could decide you want people to get a baseline on so that you can use them when you describe your sample. And so they take all those measures and you randomize them into two groups. One group gets fruits and vegetables for breakfast. The other group gets Fruit Loops. Okay, so you've got a treatment group and another treatment group. You don't have to have a control group per se. You don't always have to have a group that does nothing. Sometimes we already know that a treatment has some effect. And so we call it like a waste of subjects or waste of participants, a waste of resources. And it's sort of frowned on in the world of research to waste resources when you already know something. And so it's okay to just compare two different treatments. That totally works. For example, if you're looking at therapy, nobody does studies to see if therapy works anymore. That's considered a waste. Having a treatment where people just don't get any therapy to see if therapy at all works, we know therapy works. And so what's more useful is comparing one therapy to another therapy instead of to no treatment, because we know treatment helps. All right, so you've got randomization. You have to figure out a way that you randomize. A lot of times people use a random number table or random number generators from a computer. You can enter people into a statistical program and just say randomize them to groups, and it will randomize them using the computer's random number generator, and it's perfect. It's great. So you randomize the groups, and then you end up with two groups, and you're hoping that they're equal in their baselines. You give them the treatment, and then you give them the operationalized measure for anxiety at the end. So you give them the state anxiety test at the end of their number of breakfasts, however long that lasts. Let's say you did it for a month. And after a month, you give them the state version of the STAI, and they take that, and then you get to compare the groups. And so the question is, how do you compare two independent groups? They're independent because they're not the same people, right? And so you had a group of people, you randomize them into two different groups. They're two different groups. They're not the same people, so they're independent. Each person takes a test. You look at the average anxiety score of each test. So you have two means, one anxiety mean for one group and one anxiety mean for the other group. If they're different, you find that out by comparing them using an independent samples t-test. Okay, t-test. So why is it called a t-test? Well, I have to tell you this little story. I think it's a little amusing. It's called a t-test. Well, that's the number. That's what they call the value at the end of the equation. So you run this mathematical equation, and then you get a value they call t. And you look up t to see if it's statistically significant or not. You don't do this anymore. You used to do this. You used to like open your book and you'd look in the back of the book, and they'd have these long tables of t values. And so you look up your t value and see if it was statistically significant given some other parameters of the study. Nobody does that anymore because your computer does it all for you. Just boom, shakalaka. There it is, right? Okay, so the origin of the t-test, kind of interesting. This guy named William Seeley Gossett, he was from Oxford, and he worked for the Guinness Brewing Company in Dublin, Ireland. Now, Guinness had a habit of hiring really, really top-notch people for its chemistry and statistics and science guys. They just wanted the best. So they looked at Oxford for who was really, really awesome. And they hired this guy, William Seeley Gossett. And so one of the jobs that he had was comparing the quality of their stout, their line of stout beers. And so he came up with the T-test as a way to measure quality differences in stout beer. Now, here's the interesting part. If you notice, sometimes in books, you may notice in your book, sometimes it's referred to as student's T-test. This totally confused me when I was undergraduate, graduate student. I sort of skipped over it because I'm like, okay, whatever, student's T-test. What is this about? Like for undergraduate students, this is like a less sophisticated thing. I don't understand why they call it student's T-test. Here's why they call it student's T-test. It has nothing to do with being a student, nothing at all. The reason is this, because William Seeley Gossett worked for Guinness, and Guinness did not allow anyone who worked for them to publish anything independent of the company. So he made up this test, a great statistical test, very, very useful. It's used like a gazillion times now. And he was not allowed to publish it under his name. And so he used a pseudonym to publish this test. Now, he had sort of affectionately been called, or his nickname was Student. That was his nickname. And so if his nickname had been like Ringo, right, it would have been Ringo's T-test. But it wasn't Ringo, it was Student. And so it's student's T-test. It has nothing to do with being a student. It's just his nickname, and it was his way of being able to publish this outside of Guinness being in control of it. Interestingly, after that, he went and worked a little bit in the lab of Pearson, who the correlation is named for. Pearson, the Pearson R. And so they knew each other. Kind of interesting. All right, so that little foray into history and fun stuff. Well, let's come back to our study design and choosing particular appropriate statistical tests. So right now, you have one down, 2 independent samples, and you use students' independent samples T-test. All right. The next thing you want to look at when we're looking at this study of eating breakfast, vegetables and fruits or Fruit Loops, right? Let's just take a look at what is the study design. Is it a study of association or a study of causation? Which one? So I want you to just sort of think about this, because you're going to have to identify in your research proposal, is your study a study of frequency or association or causation? So obviously this can't be a study of frequency because you are manipulating a variable. You're telling people which breakfast they're going to eat. If you just did a survey of all of the students who ate breakfast and what did they eat for breakfast, that would be a frequency study. But here we're trying to figure out, this study that we're looking at, is this a study of association or of causation? Okay, there are 3 things you need to establish if it's a study that can handle causation. Causation is a big deal. We don't like to toss that off easily. You have to really prove some things to say this causes this. And so there's 3 things you need. One of them is that the thing happened before the effect, right? We call this temporal precedence. The cause has to happen before the effect happens. You think, well, duh, right? And I know, but you'd be surprised how useful it is to really take a look at this when you're examining causation. Was temporal precedence kept? Okay. The second thing is those 2 variables that you're looking have to co-vary. They have to have a relationship. You can't have causation if there's no relationship. And so you have to demonstrate that those variables co-vary, that they are associated. Okay, so something that will help demonstrate association, correlation maybe, something like that. The last thing is you have to control all the alternative explanations. And this is the hardest part, getting that control so that you can have what we call internal validity for your experiment. Internal validity means that the thing that affected your outcome was the independent variable and nothing else. It was the independent variable that made the difference, not the wind blowing or, not somebody dropping their pencil. It was the actual breakfast that made the difference. And so if you can control all the other alternative explanations, then you can be more confident in saying that you have a study of causality. But this is really difficult. It's hard to think of all of the variables you have to control. It's hard to actually control all those variables. Let's say there's something that happened. Let's say you did this experiment, and while you were doing the experiment, it was also finals week. Well, this would affect your results, don't you think? For sure it would. Let's say that while you did this experiment, there was a series of tornadoes. This would affect your, let's say while you did the experiment, there were people randomly walking around campus handing out Snickers bars, right? That would affect your results. And so you have to control all of those potential alternative explanations for what you got, internal validity. And so generally, we don't have enough evidence with one study, often with 2 or 3. You have to have the preponderance of the evidence on one side, or the weight of evidence that indicates this is a causal relationship. So multiple studies, you need more data. That's why we replicate studies. Okay, the next thing, I'm moving me over here. Okay, control. When we say randomized controlled trial, what does it mean to be controlled? Does it mean you have to have a placebo? Does it mean you have to have a control group that gets nothing? So this is a great question to ask. Control simply means there is a comparison group. In other words, you have one group that you're looking at, and then there's another group you're comparing it with. So hopefully a control will give you a sense of some other thing happened to interfere with your study and create a difference in your results, like people running around handing out Snickers bars, or tornadoes happening, or, you know, COVID, something like that, right? Control simply means there's a comparison group. You can give a comparison group a placebo. You can give them no treatment. You can give them another kind of treatment. The idea is that there's a comparison group. Okay. So, type of design. We had this list, you may have remembered it from last week from the SmackDown rubric. So there's all this list of there's all these types of designs on this list. And so I'm just gonna point out what we're looking at is a randomized controlled trial. Okay, we are changing the breakfast that people are getting. We're randomizing groups. The control is because we have a comparison group, so it's randomized controlled trial. It's not blinded, right? Obviously, it can't be blinded the way we're running it. People will know if they're eating fruits and vegetables, and they will know if they're eating Fruit Loops. We could maybe create some kind of similarly flavored breakfast bar that contains those things and it's flavored the same. That would be a lot of work, and it might not work very well because people wouldn't have very much pleasure possibly in their breakfast. Maybe that would affect it. It's awfully hard to control these things. So in our case, in this experiment, it's not blinded. It's not blinded for the people. Now you can blind it for the researcher when they analyze the statistics. You can blind them to which group is which. So as they're analyzing, they won't know. That's kind of the best you can do. All right. Okay. So then we're going to move on to example 2. Okay. So just to quickly remember where we are. Example 1 was you have 2 independent groups, and you're looking for how do you find the difference in the means between 2 independent groups? And the answer is an independent t-test or student's t-test. Okay. Now we're going to look at one group. We're just going to look at the effect of eating vegetables and fruits on anxiety. Okay. Just one group. So what we want to do is compare SVU students to a known population average. And so if SVU students are eating fruits and vegetables, they should have a particular amount of anxiety. Sorry, distracted. If SVU students are doing nothing, they should have a particular level of anxiety. You could just take an overall population norm in SVU and say, this is what the SVU population norm is. Let's now compare the fruit and vegetable eating students to regular SVU students. 1 second here. Okay, I'm back. That was a wild and crazy washing machine. that had something in it that was making it really off balance. And I don't know if you could hear it, but wow, I was totally distracted. Okay, it's gone now. So we're looking at one group. How does one group's mean score, average score, compare to a population, a known population score? So you may know the whole SVU group population score. I don't know that off the top of my head. Maybe somebody has done that research and we know. I don't know if they have or not. But we do know average college student scores for the STAI. And so the average college student score is around 37 or 40. So you can compare the SVU group that's eating fruits and vegetables for breakfast to known college students' anxiety scores. Your study has one group, the students who eat vegetables and fruits for breakfast, the end. You ask them to take the STAI after, let's say again, they're eating fruits and vegetables for breakfast for a month. And so you're looking at their test score on anxiety versus the population test score. If you did a pre and post test and you saw some change, that would also be interesting. But because you're doing the study anyway, it makes sense for me that you would compare pre and post. If you're comparing pre and post, that's actually a different test. So take that out of your mind. What we're doing here is comparing one group to a population average, okay? So this is what our design would look like. You have the recruitment, you enroll them in the study, you don't randomize because it's just one group. And so you're only looking at one treatment group and a follow-up, and then you do your analysis. Okay, one group, everyone takes the anxiety test, you calculate the average anxiety score for the group. So you have one mean. Make sense? One mean. And so the question is that mean different from the average college student or from the average, I don't know, the person who went to Africa for a study? I don't know what you want to decide. Compare it to anybody you want, but the idea is you're comparing one group to some known population mean. So you use a one sample t-test. The other one was an independent samples, two independent samples t-test. Here, you're using a one sample t-test. And so you're exploring, is our groups different than the known population? Okay. Interestingly enough, here's another side note. We're going to go off and learn a little bit of something else. If you have students that are deep learning, they have lower anxiety than surface learning students. So this came up because I'm looking at population norms for the STAI. And population norms were studied in a particular group of medical students. And so they looked at how medical students were learning, what their learning style was, and what did their anxiety look like? What did their STAI scores look like? And they found that most of the students in medical school were deep learners. Now this made me feel better because I would like doctors to be very competent and good at their jobs and interested in what they're doing. And so I think it was something like 70% of the students in medical were deep learning style students. That means they really know the material, they kind of incorporate it into their own experience. And they learn it in a way where it is well processed. Think back to Gen Psych, maybe you learned a little bit about this. So the surface learner, on the other hand, aiming at minimal requirements, learning is just, copying it. How can I reproduce it? I'm going to learn it and then I'm going to just do it the same exact way you tell me to do it. And so all they're doing is cutting and pasting, really, with some mild modifications. You can see how this is very surface learning. People aren't really learning the concepts. And so I bring this up because I think it's important at your stage in schooling to take a hard look at what kind of a learning style you have. And if you have a surface learning style, here's the interesting thing. It's related to much higher state anxiety. I mean, that's not a good plan, right? And so surface learning creates anxiety. Deep learning, people may avoid deep learning because they think, oh my gosh, that seems so hard. I'm just going to do the basics. I'm just going to do the minimum of what's required. And then it'll be easier. But the data shows that no, it's actually more anxiety provoking to learn that way. It is less anxiety provoking to do deep learning. Cool? All right, so I hope that was valuable for you. All right, now we're ready for example 3. So example 3, we're looking at the effect of eating fruits and vegetables versus cereal for breakfast or on anxiety in SVU students, but with 3 groups. Okay, so instead of just looking at 2 groups, vegetables and fruits and cereal, we're going to add a 3rd group. And we'll just say you guys have a regular breakfast like you would always have. And so now we're looking at 3 groups instead of 2 or 1. And all the groups take the same, it's like the same basic design. They all take the STAI. You want to compare their scores. And so here you can see my crude drawing of a 3rd group in red. You can laugh at that. Oh my gosh, look, she's so cute. Yeah, I know. So 3 groups. Oh, and I'm blocking my picture of my 3rd group. So again, I have to move myself. All right, so you recruit them, they're enrolled, you randomize them to 3 groups. Each of the 3 groups has their breakfast for however long it takes, and then they take the STAI at their follow-up. Their follow-up might be at 1 week. It might be the same day that they finish. It could be 3 months, 6 months, 12. It's, you know, you choose. And then you analyze the data. Okay, and so how do you analyze the data? Each group takes the test. You have 3 means now, 3 independent samples. How can you figure out if all 3 at the same time are different? So there's a test called ANOVA, analysis of variance. Analysis of variance, or you can have an ANCOVA, which is an analysis of covariance. ANOVA is an analysis of variance, and COVA is analysis of covariance. You can use, depending on the parameters, a little beyond where we are right now, but I just want you to be familiar with those 2 terms. How do the groups covary? How do they associate with each other? Are there differences between the 3 groups in their means? Use ANOVA, analysis of variance. Okay, finally, we could look, I am just in the way, right? Finally, we could look at fruits and vegetables and cereal on anxiety in 1 group of students. 1 group gets both treatments. So when we talked about between subjects and within subjects, this is an example of within subjects. Between subjects is what we've been talking about with the 2 and the 3 groups. 2 independent groups, 3 independent groups, and you're looking at the impact of the treatment, the different treatments on each group. Here, we're using 1 group to look at both treatments. And so everyone in the group will get both treatments. So they just get them in a different order, or they get them at a different time. So you may have part of your 1 group has spinach for breakfast, and the other part has Fruit Loops. And then after, you know, a month, they take the they take the anxiety inventory and they switch. That's also called a crossover design, using within subjects. But basically what you're doing is you want to compare scores of the same people at 2 different time points. Now, we also did this when we talked about pre and post. And so if you take a pre-test and then a post-test, you're the same person that took each test, right? And so there's some amount of variance that is accounted for because it's you. You're the same person both times. And so there's a little bit more power here because we don't have to worry about extra variance that's out there. We have a lot of variance accounted for that you're the same person both times you took the test. And the difference is really about you and what breakfast you ate. And so if you take a pre and post and you look at the pre versus post in the same group, that is also within subjects. Okay, makes sense? So you could do a crossover study that would be within subjects, or you could look at a pre and post within subjects. And so it is a paired sample t-test. Paired sample means that the sample you're looking at is paired with themselves at another time point. 2 treatments, 1 group. The test is given after each treatment or pre and post, something like that. Are the means still different? You find out by comparing with a paired sample t-test. Okay, so to review, independent samples t-test looks at the means for 2 groups. Paired sample t-test looks at the means from the same group at different times. 1 sample t-test looks at the mean of a single group against a known population. And then ANOVA compares the means for 3 or more groups. Right, okay. Okay, so that's how you compare means. Next, we're going to test relationships. Is there a relationship or not? So this is basically the DTR, right? Mathematically speaking, determine the relationship, right? It's easier to put it, it's actually easier to have an actual DTR conversation, right? Then it's easier to do this than have an actual DTR, I think, because you're just putting numbers in equations and that's not usually that painful, right? So what you're looking for again is what kind of relationship does each group have with each other? Is it a positive relationship? So remember, positive can be both go up at the same time, both go down at the same time. Both of those are positive relationships. Or it can be an inverse relationship. A negative relationship is an inverse relationship. So negative, inverse, like this. One goes up, one goes down, okay? Negative relationship is not that they both go down at the same time. That's a positive relationship because they're moving together, so it's positive. So think, are we moving together? Well, that's positive. That's a positive thing in our relationship that we are moving together. Kind of think of it that way. All right, so both your variables are continuous. If they are, then you use a particular kind of test. If they're not continuous, you'll use a different kind. So we're just going to learn these last two things for this section, okay? So deep breath, you can do this, okay? We've got comparing the means down, and now we're starting on testing the relationship. Only two more to look at, okay? When both of yours are continuous, like, does the amount of excitement about research methods that you feel correlate with the grade you get in the class, right? Like, how nerdy is that? I don't know. That was the example I came up with, go figure. So it's one variable, which is the amount of excitement. That's a continuous variable. And the other variable is your grade, which is also continuous. And so you would use the Pearson R. Remember the guy that William Gossett Seeley went and hung out with after he published the student's t-test, right? Like, this is knowledge you could excite your family with at dinner time. So you use the Pearson R or the correlation. You correlate those two, and you use a Pearson correlation because they're continuous. You could use regression if you wanted to predict. So regression will predict, but generally you would use correlation. If, on the other hand, you're not looking at continuous variables, but you're looking at categorical, nominal variables, like the gender of your classmates. Does the gender of your classmate have any relationship with whether or not they get their homework done? So gender is one, that's category. Getting homework done or not getting homework done, that's another category. And so you're looking at two variables that are categorical. You can't use a Pearson R. You can't use that Pearson correlation because that has to have continuous variables to be able to work mathematically. And so instead, what you have to do is use what they call a chi-square. A chi-square test will look at the relationship between categorical variables, and they will tell you if males tend to do one of the other, or if females tend to do more of one or the other. It will tell you if there's a relationship or if there's really no relationship between those nominal variables. Chi-square test. Okay, so that's where we are. End of chapter 9, more about statistics. Okay, so we looked at comparing means, we looked at testing relationships, and we found a number of ways to use statistics to figure out if there's a difference in terms of what you did in your research either between groups or between observing what you're looking at and some sort of known population. All right, so now we're gonna go on to survey research. This is chapter 10. What are the pros and cons of doing survey research? And we're not going to spend a lot of time on this because you're going to do kind of a really fun activity that I think will help you more with survey research than listening to blah, 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 more of this. Okay. So the pros of survey, they're easy, they're quick to create. You can do them remotely. You can get a lot of people doing them. I saw some sort of survey that was offered by, I can't remember the company. They said, we're going to give you a $5 Amazon certificate to do this survey. And so I clicked on it like 27 times. And every single time it said, we're busy. There are too many people taking the survey. I thought, okay, so you maybe, oh, I know, it was like a Grubhub or something. And I'm thinking, well, I guess you got good results. I guess you got a lot of people to take your survey, because either you quit and you put that up, that message up as please stop, or you really have so many people taking it that it's crashing your site. It's crazy. So that's a pro to survey research. You can get a lot of data pretty quickly, especially if you offer, apparently, if you offer $5 survey gift cards to Amazon. The cons, you could get response bias. You know, you get some people that are really, really interested in answering that survey and they click 2,727 times. Well, they're probably more likely to get in than I did. I gave up after like 27. So what are the kinds of people that would be that persistent? Maybe that is going to give you a selection bias. You might get tired of taking the survey. Let's say the survey is 117 items long, and by about item 87, you just don't even care anymore. And so you're just like making pictures in the air, and when you select the answer on your computer or something. So we call that survey fatigue. Maybe your questions really are awful, and so that leads you to wrong conclusions. Or let's say they're watching a TV show while they take your survey and they lose track of where they are and they sort of skip a few. And then you have this idea that they gave you actual data when what you got was just error data. So there are pros and cons to surveys. Surveys can be like a poll, you know, or like a questionnaire. So sometimes we say we're going to give you a survey for anxiety. People will say that. Just know that that term kind of interchangeably means we're going to give you a questionnaire, we're going to give you a survey, we're going to give you a test. You know, sometimes we use, it's confusing. That's just how people do it. And so I'm just kind of alerting you to this so you don't get confused and stuck on one particular vocabulary word meaning exactly one thing. I mean, have you been to America, right? Okay. So constructing a good survey, you need to put a lot of thought into it, a lot more thought than people think. So let's look at some of the things that you have to know. So what's best, what's best is that if you find a already constructed, validated, reliable questionnaire, use that. That's your best bet. It will probably do the job. Like the STAI is a great example of a well-constructed, validated questionnaire. Good reliability, widely used, widely accepted. It's a good call. However, if you're studying something where there's no good measure for what you want to study and you end up having to make the measure, then that measure has to have at least some preliminary validity and reliability data. And this would include this list of things: construct validity. In other words, are you actually measuring the construct that you mean to measure? Let's say the construct you mean to measure is state anxiety, but your question has to do with ice cream. So that doesn't have good construct validity. You're not measuring anxiety, you're measuring ice cream, okay? So validity, remember, validity means it measures what it purports to measure. So construct validity means that it's going to adequately capture the construct that you intend to be measuring. Face validity is less important than many of these ideas, but still it can be important. It can be a part of validity. Face validity just means it looks like it measures what it says it measures. And so if it's a measure for anxiety and it asks me how frequently I do laundry, I'm thinking, okay, that doesn't seem to have anything to do with anxiety. That has no face validity, okay? Now, what if how much I do laundry legitimately has a relationship with how much anxiety I have? Like, I doubt that, but what if that was true? If it was true, then it would still be a valid question. It would just have low face validity because I wouldn't know that that was true. I wouldn't already know that. Okay, face validity. Criterion validity means, does it match something that we know indicates validity? So we know this is about anxious people, and is there a question like that on this test? That would be like a face valid question, but if there's a question like this on this test, then that's related to some empirical evidence. That would be criterion related validity. So let's say we look at the STAI and we compare it with another test for anxiety. Let's say it's like the Beck Anxiety Inventory. So we look at that. That would be criterion related validity. It could say, or we look at, patients that have a known anxiety disorder and we ask them to take the STAI. We would hope that their scores would be higher since they have a known anxiety disorder. So that would be called, they would be the criterion group. That would be called criterion related validity. This is review. We went over some of this before. So if it sounds like review, you're not crazy. We did talk about this. I just want to make sure that you have it down, in particular, how it relates to surveys. Okay, surveys, you also want it to have some discriminant validity. Now, of course, we're not talking about like a political poll that says who are you going to vote for. That doesn't really have discriminant validity. You know, the validity there really depends on who you actually vote for. Are you telling the person accurately who you would vote for or not, etc. Okay, so discriminant validity would mean that it doesn't match the things that it's not supposed to match. So there's no relationship between anxiety and particular kinds of ice cream that are loved, right? You don't want there to be a relationship because anxiety and ice cream shouldn't have very much to do with each other. Then there's test retest reliability. If you give the test on a Monday and you give a test on a Tuesday, do they get the same score? Like they should get pretty much the same score unless something really seriously different happened on Tuesday versus Monday and we're looking at a state variable, like state anxiety, okay? Internal consistency is a measure of reliability. Internal consistency really means that the whole test kind of measures the same thing. So if you have a test that looks at how many shoes you like, what kind of flowers make you the happiest, and anxiety, that test is going to have low internal consistency. Parts of it have to do with anxiety, parts of it don't. And so a test that has internal consistency that is a higher level is considered more reliable, okay? So if you're trying to make a questionnaire to use in your study, you have to first do a study of the questionnaire. And so I would encourage you to not make up a questionnaire. It won't work very well. If you have to make up a questionnaire, then you're taking on so much more work that making a research proposal to do this, I just think that's not a good plan because you're gonna have to do more than one study. You have to do a study on your questionnaire to make sure the questionnaire works. All right, let me also point out, Chapter 10 gives you some places where you can go find lists of psychological questionnaires. So that's a good resource for you to use for your papers. Okay, when you word questions, and we're almost done here. So take a breath, take a drink. Here we go. Almost done. Likert scales are used often in a questionnaire. Likert scales, when they say, you know, 0 means that's never happened, or often 0 to 7. 7 is all the time, 0 is none of the time. 1 is almost never, 4 is almost always. That's basically your Likert scale. Frequently they're 1 to 5 or 0 to 5 or 1 to 7. It's frequently something like that. A little more rarely there are only 3 different options. A lot of times we try not to have something where people can pick the middle one all the time, because then that just leads them to say, yeah, I don't know, average, it doesn't matter. And then there's no interesting variability. Nothing really, their answers don't really lead to anything because they're basically saying, I don't know. So they're useless, right? All right, so that's a Likert scale. A lot of times you find that as a way of responding to a survey. That's a closed response. It means that you can kind of not figure out what exactly they're saying and the same person can be compared. Open responses you have to look at individually. You usually do this at a very preliminary level when you're still constructing your questionnaire so that you can get ideas. Okay, so the way you word your questions is a big deal. And I would suggest reading through this area in Chapter 10, but also we're just gonna go really quickly through some of the things. I'm expanding a little bit more than what is in Chapter 10. We talk about double-barreled questions in Chapter 10. This is basically using 2 questions in one. Like, do you like chocolate and do you like your chocolate in ice cream? And so you can't say yes or no to that because it's 2 questions. That's a terrible question. Leading questions. Leading questions are things like, you know, since it's such a good idea to use a car seat, do you think that parents that don't use car seats are bad parents? Well, that's a pretty leading question, right? You're kind of pushed into an opinion on that one. Double negatives, using absolutes like you always, you never, I always wake up at the dawn, at the crack of dawn. Like that just, nobody's gonna say yes to that because I don't think there's any person who has always, every single day for their entire life, woken up at the crack of dawn. Using clear language, non-jargony, non-technical language, so that people understand. If you're saying, do you use a GTX 480 in your daily work? People will be like, I don't know what you're talking about. That makes no sense at all. And I agree, it makes no sense at all. But I've heard that word a lot in my house. Okay, here is an example of some really bad questions that I thought I would give you so you can see some bad question examples. So for example, this one, do you know about the Sociological Department's program, Concentration and Analysis and Research? The only options you get are no, a little, and yes, fully. So what if you know yes, a little bit? What if you're not sure? You've heard of it. You know, it's, you need a little bit more between a little and yes, fully. Okay, that's one example. How happy are you? Same kind of thing. Very happy, moderately happy, and then there's nothing. It's like unhappy. That's the only other option you get. Not a good question. So number 27. This one is not a good question because the way it is lined up is really just wrong. So you've got 7 through 1 underneath the value holders, very pro-choice to very pro-life, but they don't match up. And so you could look at completely neutral and write down 2. And if, you know, especially if you're going quickly and you think, well, that captured my response, when in actuality, that looks a lot more pro-life than a completely neutral answer would be. So completely neutral would be 4, but 4 doesn't look like it should be that. So when you're designing your questionnaire, you want to make sure things line up and they look right. These days, that's a lot easier to do because you have companies that run surveys that make them so that it's hard to type it out on a paper and create this kind of a problem these days. All right, so next one. This one is a great example of really problematic answers that don't capture the full range of what people might think. Because you either, okay, this is like before you were born, all right? I either support President Reagan and oppose any campaign that would weaken our defenses. Okay, so that's double-barreled, right? And then I'm willing to prevent our defenses to weaken, and I support the extremists. Okay, well, is that a little bit of a leading question or what? It's a very leading question. All right. And then the last one, of course, do you do Coke? What does that mean? I'm just going to say, are you saying diet or real Coke or Coke Zero? I'm sure you're not talking about anything else, right? Like, who knows what they're talking about? That's a bad question. All right. After you complete a questionnaire, then there's a scoring key. And you look at the key and then you look at your response and you compare it to norms. So a scoring key is usually based on norms in the sense that you're comparing the number you got to something that makes sense to you. Like, let's say I give you a test called How Much I Love Ice Cream. I don't know why I'm obsessed with ice cream today. I don't know. But it's just the thing that's popping up in my head. So how much do you love ice cream? Well, here's your score, 47. And you're like, okay, well, great. What does 47 mean? I don't even know what that means, right? So you need norms so you can figure out what that does mean. Now, if the average American's love of ice cream is 62, then you'd say, oh, wow, I love ice cream less than the average American. If the average American's love is 20, then you can be like, wow, I am really going for it on the ice cream. So in order to come up with norms, you have to have enough preliminary data to have a good sense of what that average person's response is. Or you can look at different kinds of groups. You could say, what is the average man, the average woman? What is their score in terms of love of ice cream? Or you could say, what is the average psychology major versus musician versus biology major? What is their love of ice cream? And then you can have different norms for different groups. So you could take your score and say, okay, I got a 47. The average score for men liking ice cream is 22. The average score for women liking ice cream is 63. I'm making this up. I have no idea, really. You could do this study. You know, maybe that's what you need to do. But the average score for musicians is 48. And so I'm scoring right in alignment with average musician score. So that's kind of interesting. All right, so here's your activity. I'm going to give you clear details on Canvas, so don't worry about writing this down. I just want to introduce it to you. What I want you to do is build a 7-question survey. You can choose anything you like. It could be a survey about whatever you want, whatever is easy. Honestly, I would suggest something easy. 7-question survey using these guidelines. Make a scoring key by administering your survey to enough people so that you have a sense of what a norm might look like. And so we're just going to go really small and simple. And I'm going to say, if you're going to do 2 different groups, try and get like 4 people per group. You know, Facebook, some friends. You must have 4 friends in the world, right? So Facebook some people and say, hey, how much do you like ice cream? And what's your major in college? Or how much do you like ice cream? And what's your gender? And what's your hair length? I'm like, I don't know. Like, you pick something so that you have a sense of norms for your survey. Then you're going to submit this survey to a discussion board. We'll do this at the end of I don't want to say the week because that's going to be due later than in a week. It'll be due April 13th. Okay. So after spring break, the Monday after spring break is when it's due. So you've got 2 weeks to work on this. Work on it until then you submit it to a discussion board and we'll use it that week. We'll have each other take our surveys and you can get a little bit more of a feel of what that data look like. All right. So I'll give you more details in the Canvas activity, and that I'm hoping will be fun. Here are a couple ideas for surveys in case you want some something to get started with. Traditional ideas about gender roles. Are you a movie expert? Do you love dogs? A dog loving survey. All kinds of different ideas. Look around. All right, here's an example. So let me walk through this with you just so you can see me do it a little bit more. Let's say I wanted to create a survey on how sophisticated a chocolate lover you are. So first of all, I'd find a group of really picky chocolate eaters. People that I know are very, very picky or very sophisticated about their chocolate taste. And then I'd ask them, what are the kinds of chocolates that you like? And what do you hate, or what won't you eat? What will you eat? What won't you eat? Where do you draw the line in terms of chocolate acceptance? And then I'd find some people that liked chocolate and didn't care where it came from, didn't care what kind it was, totally non-discriminant chocolate eaters. And so then I come up with some sample questions, and we'll see if those questions seem to discriminate between the groups. In other words, if one group says yes and the other group says no, then I'm thinking, okay, that's a good question because it helps me determine which group you might belong to. And so if my question is, what do you do when your roommate gives you a Whitman sampler of chocolate? You've seen those in the stores, or Russell Stover, right? What do? You throw it out. I wouldn't give it to my worst enemy. Meh, I'll eat it, but I wouldn't love it. I love it. It's in a box, right? It's chocolate. So those are 3 potential answers. Maybe you could come up with some others, but that would be maybe something you could do for chocolate, for sophisticated. Then I use their responses to build a questionnaire. I give each person the questionnaire, make sure it works. And then I think about how am I going to choose a score that will create the most efficient cutoff so that I have the best chance of putting a person in one group or the other correctly. So that's kind of a statistical question, but it's a thought question. I just want you to think about this interesting question. You know, when you're taking a long drive in the country, looking at all the COVID, you can think about this question because I know that's what your life is. How can I find a good cutoff score? Oh, look, there's a place where there's not in business anymore. How can I find a good cutoff score, right? That's what it is. Okay. All right. We're going to do another Smackdown Thursday. It's going to be short. Finish the quiz or activity from last week. It's due this Saturday. Start the survey activity due Monday, April 13th. I want it on that Monday so we can have it for the week. All right. So I'll talk to you soon about our upcoming Smackdown, which is going to be the one that's horrible, right? That'll be fun. All right.